Alright, I'm going to go over the homework from page 228, numbers 28 through 31, in case you need some help with that. 28A asks you to do the net ionic equation for this reaction. So again, the first thing I'm going to do is I'm going to balance it. So I have one lead, 2 nitrates, 1 nitrate. I need a coefficient of 2. I have 2 hydrogens, I have 2 hydrogens, I have 1 sulfate, I have 1 sulfate, so it's balanced. Next, I'm going to do a complete ionic equation. Again, that means I'm going to break up everything that's in the aqueous state of matter into its ions. So I'm going to have Pb with a +2 charge, aqueous, plus 2 nitrates because of that subscript, plus 2 hydrogen ions because of the subscript, plus sulfate, yields, again, PbSO4 stays as is because it's a solid, and I break apart 2 hydrogen ions, aqueous, and 2 nitrates because of the coefficient in front. So that's my complete ionic equation. To get my net ionic, I have to identify my spectator ions. So nitrate is in the same form on both sides of the equation, and hydrogen ion is in the equation the same way both sides. So that makes my net ionic equation Pb plus 2 aqueous plus SO4 negative 2 aqueous yields PbSO4 solid. Again, you don't have to do the complete ionic equation. I'm just doing it to help the people who are struggling. For letter B, balancing this, 1 lead, 1 lead. Okay. 2 acetates, 1 acetate, I needed coefficient of 2 in front of hydrogen acetate. 1 hydrogen, 2 hydrogens, need a coefficient of 2 in front of hydrogen chloride. 2 chlorides, it's balanced. So now I'm ready to do my complete ionic equation. Again, I'm going to break up everything that's aqueous into its ions. So Pb plus 2 aqueous, plus I'm going to have 2 of these acetates, two hydrogen ions, and 2 chlorides. And lead chloride stays as is because it's a solid. And then I'm going to have 2 hydrogen ions and 2 acetates because of the coefficient in front. Again, looking for my spectator ions to get rid of. 2 acetate, so that'll be gone. And 2 hydrogen and 2 hydrogen, so that'll be gone. So that makes my net ionic equation for this one, Pb plus 2 aqueous plus 2 Cl minus aqueous yields PbCl2 solid. Letter C, again I'm going to balance it first. 3 sodiums, 1 sodium, I need a coefficient of 3 in front of sodium chloride. 1 phosphate, 1 phosphate. 1 iron, 1 iron. 3 chlorines, so it's balanced. Next I do my complete ionic equation, again breaking apart everything that's in the aqueous state of matter. So 3 sodiums plus phosphate plus iron, and it has a +3 charge. I know that has a +3 charge for iron because, again, I can either reverse crisscross or kind of figure out the charges. 3 sodium ions and 3 chlorides because of that coefficient. And then my iron phosphate solid. Again, my spectators, sodium and chloride. So that means that my net ionic equation is phosphate ion plus iron ion yields, my stomach is growling, even though I just ate breakfast. Okay, so there's your net ionic equation. It doesn't really matter what order you write your reactants in. Letter D, again, I'll start with balancing 2 ammoniums, 1 ammonium, I need a coefficient of 2. Okay. 1 sulfur, 1 sulfur, 1 cobalt, 2 ammonia, 2 nitrates, so it's balanced. So my complete ionic equation, 2 ammonium ions plus 1 sulfide plus 1 cobalt with a +2 charge plus 2 nitrates. Again, I'm breaking apart everything that's in our aqueous state of matter, so I leave cobalt sulfide alone. Right, and then I'm going to have 2 ammoniums, aqueous, plus 2 nitrates, aqueous, spectator, ammonium, and nitrate. So my net ionic equation is sulfide plus cobalt yields the cobalt sulfide solid. So there's my net ionic equation for letter D. Number 29 asks us to write a net ionic equation for each reaction. The difference this time is they don't give us the product. So again, we have to identify this as the type. This is 2 compounds reacting, so this is a double replacement reaction. Hydrogen and silver are going to swap partners. So they're going to be ionic compounds, so silver and chloride. And when I check my solubility rules, rule 4, chloride salts are soluble, but silver's an exception, so we're going to put solid. And then we're going to have hydrogen nitrate, and when we check our solubility rules, nitrate salts rule number 2 are soluble with few exceptions. So, there's my, now to balance this, 1 hydrogen, 1 chlorine, 1 silver, 1 nitrate, so a skeleton equation that's a balanced equation. Complete ionic, breaking up everything that's aqueous, so H plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous yields, again, silver chloride stays the same. And we're going to have our hydrogen ion and nitrate ion. I'm looking for my spectator ions, hydrogen ion, and nitrate ion. Some of you are probably seeing a pattern. My net ionic equation, that is Cl minus aqueous plus Ag plus aqueous yields my silver chloride solid. So there's my net ionic equation for 29. A, here's B. Again, I have to identify this reaction as the type. I have two reactants that are both compounds, so it's a double replacement. Lead and lithium are going to swap partners. So my products are going to be lead, which has a charge of +2, with chloride. Oh, I don't know the state of matter, so I'm going to fix that. So I'm going to look at my rule. Chloride salts, number 4, are soluble, but lead is an exception, so I should put solid. And then I have lithium with acetate. Okay, and again, acetate's not there, so this is going to be rule number 1 because lithium is a salt of an alkali metal. And it says soluble, it says some lithium compounds, but since we already have one solid product, we're going to assume this is aqueous. Balancing this, 1 lead, 2 acetates. 1 acetate, we need a coefficient of 2 in front of lithium acetate. 1 lithium, 2 lithiums, we need a coefficient of 2 in front of the lithium chloride. And now we have 2 chlorides, and we have 2, oops, yeah, I forgot to finish writing this one. It needs a 2 there. Alright, so it's balanced. Alright, complete ionic equation, breaking everything apart. So I have Pb plus 2 aqueous plus 2 C2H3 acetates plus 2 lithium ions plus 2 chloride ions. Again, lead chloride stays as it is because it's a solid. 2 lithium ions and 2 acetate ions. Alright, looking for my spectators. Here's an acetate, same symbol, charges, states of matter. Here's a lithium, same symbols, charges, states of matter. So my net ionic equation, Pb plus 2 aqueous plus 2 Cl minus aqueous yields Pb Cl2 solid for letter B. Letter C. Again, I have to identify this reaction as the type. It's a double replacement because I have 2 compounds reacting. In double replacement reactions, the metals or cation swap partners. So sodium's partner is going to be chloride. And I'm going to look at my solubility rules. Rule number 4, chloride salts are soluble and sodium isn't listed as an exception. Chromium has a +3 charge and now it's partnered with phosphate, -3. I'm expecting this to be my solid, but I'm going to check. Phosphates is rule number 5. Most are insoluble. Exceptions being alkali metals or ammonia. So this is a solid as I expected. 3 sodium, 1 sodium. I need a coefficient of 3 in front of sodium chloride. 1 phosphate, 1 phosphate, 1 chromium, 1 chromium, 3 chlorides, 3 chlorides. It's balanced. So now I'm ready for my complete ionic equation. Again, some of you probably don't have to write a complete ionic equation to get to the net. That's okay. Again, in my complete ionic equation, I'm breaking apart everything that's in the aqueous state of matter. Again, now I'm looking for my spectators. 3 sodium, so that's a spectator. And 3 chlorides, that's a spectator. So my net ionic equation is phosphate aqueous plus the chromium 3 aqueous yields my chromium 3 phosphate solid for letter C. All right, question number 30. I kind of skipped it here, but it says identify the spectator ions in each reaction in problem 29. We already did that, right? So to identify our spectators, the spectators for number 30, for this one, again, you have kind of two choices. You could say H plus and NO3 negative, or you can give their names. So it would be hydrogen ion and nitrate. For letter B, our spectators again are acetate and lithium ion, or I can write their symbols. Doesn't matter. And for letter C, my spectators ions are sodium ion and chloride, or again, I can write their symbols. Doesn't matter. 31 says identify the precipitate formed when solutions of these ionic compounds are mixed. So I don't need to worry about writing balanced equations or anything. So again, though, to predict the products, I have to know what kind of reaction. This is double replacement. Hydrogen and barium are going to swap partners. So my two products are going to be hydrogen ion with chloride. And again, nothing to do to balance that one or to write it correctly. And then barium ion and sulfate. So I don't need to balance this, but I need to decide what states of matter these are in. So for hydrogen chloride, I'm going to use rule number 4, which says chloride salts are soluble, and this isn't an exception. So this is aqueous, so that is not our precipitate. So we're expecting it to be barium sulfate. We're going to confirm that. Rule number 3, sulfate salts are soluble, but barium is listed as an exception. So our precipitate is the barium sulfate. So your options for this are you can write the formula like I have here, or you can give its name. If you're going to give its name, you have to make sure you name it correctly. So it would be barium sulfate. All right, letter B. Again, we have a double replacement reaction. Aluminum and ammonium this time are going to swap partners. So aluminum's partner is going to be hydroxide. And ammonium's partner is going to be sulfate. So again, I'm going to use my rules here. So for aluminum hydroxide, I'm going to do rule number 5, which says most are insoluble. Exceptions are alkali metals or ammonia, and neither of that. So I expect that this is my solid. I want to confirm that my other one is aqueous. So I'm looking at rule number 3. Sulfate salts are soluble, and ammonium isn't listed as an exception. So again, my precipitate for this one is aluminum hydroxide. Again, you can write its formula so long as you write its formula correctly, or you can write its name, which is aluminum hydroxide. I don't care which way you identify it. Letter C, again, we're looking for the precipitate. Once again, this is a double replacement reaction. Silver and hydrogen are going to swap partners. So silver's partner is now sulfide, and hydrogen's partner is nitrate. So again, if I look at my rules for silver sulfide, I'm going to look at rule number 5, which says most are insoluble, and again, the exceptions being alkali metals and ammonia, so I expect this is my solid. I'm going to confirm rule number 2 says nitrate salts are soluble with few exceptions, so this is aqueous. So my precipitate again is this silver sulfide. Again, I can name it. Remember, with silver, I don't have to use Roman numerals, even though it's in a short column, because it only has one possible charge. So you can write the formula, or you can write the name to identify it. Letter D, again, we have a double replacement reaction. Calcium and lead are going to swap partners. So lead's partner is now chloride, and calcium's partner is nitrate. So I'm going to look at lead chloride. Lead chloride, that's rule number 4. Chloride salts are soluble. It says some compounds of lead, so not quite sure. I'm kind of thinking this is probably my solid, but I want to confirm that calcium nitrate is aqueous. Rule number 2 says nitrate salts are soluble with few exceptions, so this is aqueous. So my precipitate again is the lead chloride. I do have to name this now because this has more than one possible charge. I have to make sure I name it correctly. So it's lead 2 chloride, or I could name it plum chloride. All right, the last one, 31 letter E. Again, double replacement reaction. Calcium and sodium swap partners. So calcium's partner is going to be carbonate. And nothing to do to write that formula correctly. Sodium's partner is nitrate. Again, for the nitrates, right, that's rule 2. They're soluble with few exceptions. So carbonate is rule number 5. Most are insoluble, and the exceptions being alkali metals or ammonia, which this isn't. So my precipitate again is calcium carbonate. Again, I can also identify it by name. Either will work. So that goes over this homework. I hope that helps or helped if you had some questions. Have a great day.